In this reaction, number of moles of HI is required. To break 1 mole of carbon and oxygen bond, 1 mole of HI is required. Here totally carbon oxygen bonds are 6 presented, hence 6 moles of HI is required. How many of the following are more acidic than phenol? Electron withdrawing containing groups phenols are more acidic than phenol, and electron releasing least acidic. At ortho is the electron withdrawing, and para also electron withdrawing to phenol. Meta nitro at meta position, nitro also electron withdrawing. Picric acid, it has 3 electron withdrawing groups, yet 246 trinitrophenol, hence it is also more acidic. Cresol has a methyl group, and methyl group is an electron releasing, that's why it is a least acidic. And paracresol also, alcohols also least acidic, and carboxylic acid is the more acidic than phenol. So totally 1 2 3 4 5, total 5 compounds are more acidic than phenol. At room temperature, how many of the following compound can decompose with NaHCO3 to liberate carbon dioxide? It is the test for acid, positive test for acid. Acidic compounds are more reactive and produces liberated. Due to 3 electron withdrawing group, it liberates carbon dioxide with NaHCO3. Similarly, ortho and para nitro also totally 3 compounds releases carbon dioxide. The total number of isomers consider both structural and stereo of cyclic ethers. Cyclic nature, ethers with molecular formula C4 and H8. If 4 carbons are in the ring, then its structure is this one. In that 3 carbons are present in cyclic ring, one of the methyl may present at a second adjacent to the oxygen, and it may be opposite to the oxygen. Here it has one chiral center, then totally 2 power 1 2 compounds are produced. One is a dextro and another one is levo, and for this like structure only one is present. It is also a chiral, not a chiral center, no chiral center, and it has only one structure. For the cyclopropyl like structure, 2 carbons are present, then here ethyl may be presented. In that similar structure, both methyl groups are present at 1 1, and to the similar structure, both methyls are presented at 1 comma 2, and here it is the chiral center which is bonded to 4 different groups. Like the structures 2 are possible, and here no chiral center because both the bonded to methyl group, only one structure. And in this structure, if the 2 methyl groups are presented cis, that is only one product is obtained because of meso nature, meso compound is obtained. And here 2 methyl groups are presented at opposite side, it is an optically active. Like this structure 2 are obtained, totally 1 plus 2 3 plus 1 4 plus 2 6 7 8 9 10, totally 10. With HI ether at least one tertiary is present, it follows SN1. According to SN1, tertiary cation is the breakage and oxygen getting negative charge. This negative charged oxygen is converted to alcohol. Finally it gives isopropyl alcohol and tertiary iodide. This is the answer one. And identify the incorrect statement. Due to the tertiary carbon, it follows SN1 mechanism. And secondary alkyl halide, it is a tertiary alkyl halide, it is the wrong option. Alcohol formed gives yellow precipitate with Na2 I2 NaOH. It is the haloform test which gives alpha methyl to this alcoholic group. There is a methyl group, so at alpha position it gives a haloform test. Alcohol formed gives turbidity with Lucas reagent within 5 minutes. It is secondary alcohol, test for alcohol. So wrong option is the second one. In the Lieberman nitroso test, the product is at para position nitrosyl. If it is involved in tautomerism, the product is, and final product is, this is the structure obtained, double bond N, and it is the phenolic group, so it is the option. The phenol when react with the phthalic anhydride gives a phenolphthalein indicator, and its structure is, to this position ketone group is substituted by the para position to the oxygen in the phenolic group. It is the phenolphthalein indicator. Chlorobenzene is not formed in the reaction of phenol treated with thionyl chloride. Phenol oxygen participate in delocalization, that's why it cannot produce chlorobenzene. In phenol, the carbon oxygen bond has the partial double bond character. Because of that delocalization, it will get a partial double bond. So both statement are true and correct explanation. Chlorobenzene with NaOH at high temperature, it gives phenol, sodium oxide. After H plus ion, it is completely converted to phenol. With concentration HNO3, it gives 2,4,6 trinitrophenol, that is a picric acid. 2,4,6 trinitrophenol is called picric acid. Aniline with NaNO2 converted to benzene diazonium chloride. This benzene diazonium chloride, the electrophilic party is substituted to para position to the OH group, is the major product. It is an aryl halide with magnesium triether. It gives the Grignard reagent. And this Grignard reagent with ether, nucleophilic substitution like product with oxygen group, the carbon anion is substituted and this oxygen is converted to alcohol. Finally, the product is this one at second option. And in this question, there is no methyl at this position. And first one is a Reimer-Tiemann reaction. In Reimer-Tiemann reaction, the products are orthohydroxy and it is a coal-base reaction. With the coal-base reaction, the product is orthohydroxy acid. Then correct option is 2. With SnCl2, nitrobenzene reduces to aniline. With aniline and NaNO2, it gives a benzene diazonium salt, N2Cl. It is on react with water, it produces phenol, benzene diazonium chloride, and react with water gives phenol. Phenol with sodium carbonate undergoes oxidation and it is the product obtained here. In this compound, totally 5 bonds are 1, 2, 3, 4. 4 pi bonds are there. And sigma bonds, here oxygen atoms are presented. Oxygen atoms, total sigma bonds are in this compound. It is the first sigma, and it is second sigma, third sigma hydrogen, fourth one, fifth one, sixth one, seventh one, eighth, ninth, 10th, 11, and this is the 12. Total sigmas are 12, and ratio of sigma to pi bond. Sigma to pi bond is the 3:1 ratio. The common name of 1, 3 diol dihydroxy benzene is a resorcinol. At 1, 2 catechol, 1, 3 resorcinol, 1, 4 hydroxyquinone. Phenol is a strong ring activating group, readily participate in electrophilic substitution reaction. And here bromine is also has a high concentration of electrophile in aqueous condition, and it is already mentioned at 3 equivalents. 3 equivalent means 3 moles of BRT is substituted, get 2, 4, 6, even though this sulfurite ion is eliminated, and the product is 2, 4, 6 tribromo, 2, 4, 6 tribromophenol. 2, 4, 6 tribromophenol is the correct one. Which of the following unlikely to cleavage? Here oxygen and phenyl group cannot cleavages by the HI. Alkyl bond is breakage. And here both are alkyl group, both can participate in, and here only alkyl group is involved in reaction, and here both are phenyl groups, no one cannot breakages involved in HI reaction. With phenol zinc dust, it gives benzene. With benzene, methyl chloride and AlCl3 alkylation reaction, methyl group is substituted to benzene, it gives methyl benzene. And with KMnO4, at least one benzyl hydrogen is presented in that carbon converted to carboxylic acid. So finally the answer is benzoic acid. Benzoic acid.